The problem statement for this project was to provide the preliminary design specifications using Aspen Exchanger Design and Rating version 8.8 for a heat exchanger system that will assist in cooling the computers of the High Performance Computer Center of Michigan State University. Some of the constraints of this project were that MSU's HPC will continuously generate 1 megawatt of thermal energy. 10 to the 6 gallons of water a day will flow out of this reservoir, which will be used for cooling. This translates to 43.8113 kilograms per second. This water will leave the reservoir at 57 degrees Fahrenheit and cannot increase more than 3 degrees Fahrenheit. The thermal energy will come into the exchanger in a liquid at 9 degrees Fahrenheit. The liquid that we chose to carry the thermal energy is propylene glycol, specifically by Dow Chemical. Propylene glycol is a liquid with a high boiling point and low freezing points. It has very low toxicity, which permits it to be ingested. It's actually a direct food additive, so it's essentially non-toxic. This will limit the danger of having any spills into the potable water. The Dow heat transfer fluids are formulated with corrosion inhibitors and pH buffers, which passivate metal surfaces to prevent corrosion, and neutralize degradation compounds, which prevent pH drop. This fluid has a relatively efficient heat transfer from -18 to 120 degrees Celsius.
The design of our heat exchanger is a shell and tube, one shell pass, U-tube bundle, seen in the figure to the right. The maintenance is easy to clean with channels and removable cover design. Corrosion inhibitor added to the glycol will limit the mechanical maintenance. Baffles inaugurates cross flow and makes turbulent mixing on the shell side. And we have 18 baffles spaced 12 inches apart, center to center. The results of our heat exchanger design was that it can handle a total heat load of 1.042 megawatts, and we were able to minimize the pressure drop in the shell to 5.53 psi and in the tube to 4.39 psi. The total price of our system came out to be $56,750. A few suppliers we found were Equipnet, whom provide used heat exchangers for a discount rate. Bell and Grosset were a very reliable and environmentally friendly company. API Heat Transfer offers standardized designs with adjustable options. All of our suppliers, we were unable to get a price because we would have to talk to a representative from the company.